Hello everyone, welcome back to my channel. So today we'll try to look into a beautiful identity. So let us write the identity. So it looks like this. So 1 plus 1 into 1 factorial plus 2 into 2 factorial and so on up to n minus 1 into n minus 1 factorial. So this sum is actually equals to n factorial. So looking this identity, it looks very intriguing, right? So let us try to show how the identity is true. So before that, we'll solve a general question for which will directly, if we solve the general question, then this is a special case of that general thing. So the question is, solve the equation 1 plus x1 2x1 x2 and so on up to n minus 1 x1 x2 up to xn minus 1 equals to x1 x2 up to xn in distinct positive integers x1 x2 up to xn. So here you can already see that it is a more generalized version. So here we have 1, that is same. Here we have product of 1, product of 2 up to product of n minus 1. So that is 2 factorial n minus 1 factorial, and here it is product of n terms, that is n factorial. Okay, so let us try to solve this more general equation. So just it is a matter of rewriting the equation. So here you can see that x1 here is there, here x1 is there, also all the terms up to here, all the x1 is there. So if I send all the terms that except this one to the other side, so that is if I keep 1 on only one side, so 1 equals to, so I can take x1 common, right? So I have x2 x3 up to xn minus all the remaining terms, minus 1 minus 2x2 and so on, minus n minus 1 x2 to xn minus 1, right? So now the thing is this multiplication is 1, so it forces x1 has to be 1. Other than that, that is not possible because both are integers. Both of that multiplication term is integers. So this forces and positive also, x1 equals to 1. So now the x1 is 1. So then we can put the value of x1 into the given equation. So maybe this we can mark as star, right? So then putting this value that x1 equals to 1, what you have from the star, that is 2 plus 2x2 plus 3x2 x3 and so on, n minus 1 x2 x3 xn minus 1 equals to x2 x, right? Now same idea. Now all these terms contains x2, and this term automatically you can say that contains x2. So if I take to the other side, so 2 equals to, I can take out x2 minus 2 minus 3x3 and so on. Right. So now the thing is the total product of two integers is 2, and both are so this x2 is positive, so other one also has to be positive. So 2 we can either write 1 into 2 or 2 into 1, right? So but here you can see that it should be distinct. So this property is important. So since it is distinct, we can only choose x2 to be 2, because x1 we have already chosen 1, so that is not possible. So since x2 is not equals to x1, we have x2 equals to 2. So now again replacing x1 equals to 1, x2 equals to 2 in star, right? So we have now two variables has been decreased. So let me check the equation once, right? So 1 plus, so it is 1 plus 1 plus 4, so it is 6. Okay, so we can write like that. So next term is 3 terms, 3 times x1, x2 and x3 and so on, right? Okay, so anyway what we have is we can, okay, that is fine, we can replace in this reduced form, that will be easier for us. So what we can do is, because x2 is 2, so every term is divisible by 2, so we can cancel x2 and this will become 1. So that will be helpful. So 1 plus 2 plus 3x3 xn. So now same idea, so you can take 3 and send everything to the other side and take x3 common. Right, so same argument, we can continue like this. So continuing this process, we get this x3 is 3 and similarly we can go on. So continuing this procedure, x equals to 3, x4 4 and so on. So xn minus 1 is n minus 1, and the last step is, so we have substituted all the values up to xn minus 1, only xn is left. So I have, so only that n minus 1 is left, and you have that equals to n minus 1. So this will imply xn is n. So I get the only solution to this system, or this equation, not system exactly. So only solution to the system or this equation star is that x1 is 1, x2 is 2 and up to xn is n. So there has to be distinct and positive. So 1, 2 up to n. And so hence our the starting identity that actually follows. So 1 plus 1 times 1 factorial, 2 times 2 factorial, n so on up to n minus 1 times n minus 1 factorial, that is n factorial. So this is the identity we wanted to prove. So I think this problem was interesting, and this identity also looks very neat. So that is why I wanted to share this identity and the proof of it with you. So I hope you have enjoyed the video. So please subscribe to the channel for more such videos. Thank you.